Okay, hi there. Today, for pre-calculus, I'm going to be teaching about the trig applications and inverse functions. So, first thing is I'm going to be tackling a lot of problems just like this one. You know, the sine of the arc cosine of 2/3. So, two things. First off is a quick reminder that the arc cosine is the same as the inverse cosine. In other words, you're looking for the angle. So if I look at this, forget the sine part for a minute. If I'm looking just at that, the arc cosine of 2/3, I'm looking for which angle gives me the cosine of 2/3, okay? So I'm going to use that to start, okay? And once you set that up, really the rest of it is pretty easy, because the next thing, once I've got the triangle all set up, I'm going to look at which part of the triangle gives me the sine, okay? So if I go over here, I've made a triangle, okay? Throw an angle. I'm going to use a theta for a symbol. Doesn't really matter, but pick one. That's my angle. Don't pick the right angle. Now cosine is adjacent over hypotenuse, okay? Which means the adjacent's the 2 and the hypotenuse is the 3. Okay, now I need to find the third side of the triangle, so like you've done so many times, you use Pythagorean theorem. 2 squared plus b squared equals 3 squared. And if you solve that out, you get b equals the square root of 5. Okay, that'd be 9 minus 4. Take the square root of that, which is square root of 5. All right, so there's my third side. Now I'm going to go analyze the sine part, okay? So I've got everything I need now. In fact, I can completely disregard this part at that point and just look at what is the sine of the angle, okay? And this part, change colors here. Now I'm really looking at what is the sine of theta. And sine is opposite over hypotenuse. The opposite of the theta is the square root of 5, and the hypotenuse is the 3, and that is my answer. Okay, so that's how we're going to do these. They look really complicated, but they're really not so bad when you actually break them down like that. Okay, so the second one, once again, I'm starting with this part inside here, the arc tangent of 3. So tangent is the opposite over the adjacent. Now 3 doesn't have a denominator, but I can give it one by putting a 1 over there. So once again, I got a triangle all drawn out. Here's theta, opposite's 3, adjacent's 1. I got to find the third side now. Remember, when you use Pythagorean theorem, it's important that c is the hypotenuse. So this is 3 squared plus 1 squared equals c squared, which will give me 9 plus 1 is 10, so that's going to be square root of 10 will be my hypotenuse. Okay, now I've got that. Now I'm looking at the cosine, and the cosine is the adjacent over the hypotenuse, and the adjacent is 1. Hypotenuse is square root of 10. 1 over the square root of 10 is my answer. And I'm just going to leave it like that. I'm not worrying about a radical in the denominator. I'm moving on. Next, number 3, arc tangent of 4x. Okay, so it's all fun and games, so someone throws a variable in there. All right, now, same idea though. Tangent is opposite over adjacent. So that's 4x over 1. So I got to put an angle in here. That's my right angle. I just keep using that one over and over again, but you can move the theta to the other. It's okay. You could have the theta up here also if you'd like. Just make sure you only got one of them. So opposite over adjacent. Now I still have to find the hypotenuse. The same rules apply. Okay, so this is a squared plus b squared equals c squared. The only thing you gotta be careful of is, you know, that you square the 4 and the x. Okay, so that's 1 plus 16x squared equals c squared, which means c equals the square root of 1 plus 16x squared. There's my hypotenuse. And now once again, I'm going over here and I'm looking at the cosine part of it. Okay, so now it's the cosine is the adjacent over the hypotenuse. So the adjacent is the 1. The hypotenuse is the 6 square root of 16x squared thing. So that's 1 over 1 plus 16x squared. And that is the answer. Next one, number 4. So, starting out here, arc cosine. Cosine is the adjacent over the hypotenuse. So, put that in there. Adjacent would be the x. Hypotenuse would be the 5, which means I'm going x squared plus b squared equals 5 squared. So therefore b squared equals 25 minus x squared. So b is the square root of that. So there's my third side of the triangle. And now I'm looking at the cotangent. So tangent is opposite over adjacent. So the cotangent is that upside down, the adjacent over the opposite. Adjacent is the x. Opposite is the square root of 25 minus x squared. And that is my answer. Number 5. All right, so arc sine. You know what? I'm going to move that theta this time. I'm going to move it, put it in a different thing. I'll put it over here this time just so you can see it doesn't actually matter which one you put it in. All right, so arc sine. Sine is opposite over hypotenuse. So the opposite would be x. Hypotenuse would be 2. Okay. And which means to find the third side, it's x squared plus b squared equals 2 squared. And if you solve that out, b is going to be the square root of 4 minus x squared. And now I'm looking at secant. So secant is the cosine upside down. So if the cosine is the adjacent over hypotenuse, then the secant would be the hypotenuse over the adjacent. The hypotenuse is 2, and the adjacent is the square root of 4 minus x squared. And that's my answer. Number 6, it's got a negative in this one. A little different. That's the only difference here so far. All right, so since the tangent is negative, I'm going to be in the 4th quadrant down here. Reminder that the tangent is primarily from pi over 2 to negative pi over 2, so it's over in here. Which, if it was positive, I'd throw it in the 1st quadrant. If it's negative, I'd throw it in the 4th. So here's my triangle, and tangent is opposite over adjacent, so that makes this negative 3, and the adjacent's the 4, which means I now got to find the hypotenuse, so I can go negative 3 squared plus 4 squared will equal c squared, and if I solve that, you get 5. It's a 3, 4, 5 triangle. And then the last thing I'm doing is I'm looking at the cosine, and the cosine, of course, is the adjacent over the hypotenuse. So adjacent would be 4, hypotenuse is 5, and there's my answer. And notice how it's positive, just like the cosine is positive. But, you know, as far as, since I made that 3 negative, that really took care of any positive negative questions. If it had been the sine, I would have gotten the correct answer, which would have been negative 3, would have been the opposite that went with the sine. So anyway. All right, number 7. Sine of the arctangent of -2/7. So once again, tangent's negative in the 4th quadrant. So here's my triangle. This time the angle in this case does go to the x-axis like the reference angle. So tangent's opposite over adjacent. So this is going to be -2 here. And the adjacent will be the 7. So when I do the Pythagorean theorem, -2 squared plus 7 squared equals c squared. And if I solve that out, you will get the square root of 53. So that's my third side, the hypotenuse. And then the last thing I'm looking at is what is the sine? The sine will be the opposite over the hypotenuse. Opposite is -2. Hypotenuse is the square root of 53, and that is going to be my answer. This one, sine -2/5. You know what? I'm going to make this a you try. I want to see you do it. I'll give you a hint though. Here is where your triangle will be, since it is the sine is negative in the in the 4th quadrant. Okay, so solve that. You do that one, number 8, and I'll give you the answer over here. If you did this correctly, you should have gotten that as an answer. Next, solve the right triangle. Okay, so I'm going to just take a triangle. They tell me what, and the angle C, or excuse me, yeah, angle C is a right triangle. That's what we're saying here. So this is going to be C. We use capital letters for angles and lowercase letters for sides. If you forget, I mean, you can just look at it and be like, oh, that one's got a degree sign, therefore that has to be the angle. Can't have a side that's 20 degrees. So that's 20. Side B is 15. Okay, and we're going to solve the triangle. So I would like to get, I can tell you right now what angle B will be, right? The interior angles of a triangle add up to 180 degrees, so therefore 90 plus 20 plus B equals 180. And if you solve that out, you get 70 degrees. So there's one answer. That part's nice. Now I need a second side of the triangle, which means I'm going to use some trigonometry, basic trigonometry. So let's say I'm looking for this one here, lowercase a, which is opposite side A. Side C is opposite angle C. So this is opposite, and this is the adjacent, which means I can go tangent of 20 degrees equals a over 15. Okay, and then make sure your calculator's in degrees. But if I take the tangent of 20 degrees, I get 0.3640 if I round off, equals a over 15. And remember, the easiest way to do these is to now cross multiply, put something over 1, cross multiply and solve, and you'll get a equals, if I multiply that 0.36 number times 15, I get 5.5. And there's one of my answers. And then last but not least, you want to do Pythagorean theorem is the easiest way to get the third side of the triangle, okay? So 15 squared plus 5.5 squared equals c squared. And if you solve that out correctly, you should get c equals 16. And now when they say solve the triangle, that means you find all the angles and all of the sides. So that one's now done, okay? Next one, given A is 52, B is 16. So I need a triangle here. It's got to be a right triangle, same directions as the last problem. C is the right angle, they told me. Doesn't matter which one's A and B. So side A is going to be 52. Side B is going to be 16. And I got to find all of this stuff. So Pythagorean theorem will be quick. We can find C that way, right? I go 16 squared plus 52 squared will equal C squared. And if I solve that out, I will get C equals 54.4. So I got that. Now I need an angle. So you can do sine, cosine, or tangent here since I've got all three sides. Let's do the angle A. So if I go sine of A equals the opposite over the hypotenuse, this will give me my answer. So I'm going to turn that into a decimal. If I go 52 divided by 54.4, I get 0.9559 equals the sine of A. And then remember, if I do the inverse, where you switch the decimal and the variable like that, I'll get my answer. Make sure your calculator's in degrees. I'm getting 72.9, which means that's that angle. This. Now, B, angle B, you don't got to do a lot of work here. Just go 90 minus 72.9, okay? Because remember, that's the inside of a triangle. If angle C is 90 degrees, then A and B have 90 degrees left for them, okay? So if that's 72.9, then the other one's got to be 17.1 when you subtract. Okay, now I've got all the angles and all of the sides. I'm done with that problem. Next one, an isosceles triangle with base angles 52 degrees and a base of 4. Okay, this one. Anybody who's forgotten, an isosceles triangle, automatically the base angles are congruent, so I put both of those being 52 degrees. I know it's probably been a while since you've studied up on your geometry perhaps, but it's a good thing to remember. What I'm going to do with this is I'm going to throw an altitude in here, okay, because I need a right triangle, which means if I drop an altitude down the middle of this triangle, life is going to be easier. And that's going to be my height, because that will give me a right angle, and now I've got right triangles, and now I can find out what I need. The other thing they don't do in here is they don't tell you that if you drop an altitude down the middle of an isosceles triangle, it splits the base in half. So this is going to be 2, and that'll also be 2, okay? And with that knowledge, now I can find out, I'd like to call this, I'm going to call this, you can find the height. What are they asking for? They ask, did I forget to write down I forgot to write down what the actual question they're asking for. So the question actually asks for what is the height, okay? So I need to solve for the h, which means with the 52, with regards to the 52 degrees, the h is the opposite, and the 2 is the adjacent. So I would like to use the tangent of 52. The opposite is the h, the adjacent's the 2. And if I solve that, I will get my answer. I don't know why I put 5 there. That should have been h. Momentary lapse of reason. Okay, so tangent of 52 in my calculator, I'm getting 1.2799 equals h over 2. Put that over 1, cross multiply and solve. I get h equals, that times 2 is 2.56. And there's my answer. Next one. So this one's a lot like this. It is from this book here where If I can get this picture, you probably won't be able to see it very well. But I got this silo, okay, and the sun makes a shadow, and they're asking how long the shadow is. It's kind of a classic kind of question, actually. So if this is, remember, the shadow is where you see the shadow. The shadow is on the ground, which means that's what I'm looking for. They're asking how long is the shadow cast, and the sun is up here in the sky, you know. Well, you can see why I never got an A in art. So the shadow is cast by this thing. It's 50 feet high. There's an angle of elevation of 25 degrees. So anyway, you're solving for the shadow, which means I'm looking at this, and you label your sides. This is the opposite. This is the shadow. Down here is the hypotenuse, which means the only one of the three ratios that has opposite and hypotenuse in it. Why did I write hypotenuse? That's the adjacent. Brain cramp. Okay, so tangent is the one I'm using. So the tangent of 25 equals 50 over x. And now I'm going to solve it, okay? So I take my calculator, I go tangent of 25 degrees, make sure you're in degrees, not radians, 0.4663 equals 50 over x. And then I'm going to put it over 1, cross multiply, and solve it. So I get 50 equals 0.4663x. And then I divide those by 0.4663. And I'll get my answer 107.2. And I believe that was feet. Okay. Getting into some bearings. All right, so these problems aren't that hard. What's actually hard is like wrapping your head around what a bearing is. Bearings are where you do the y-axis first and then the x-axis second, or the north-south first and the east-west second. A couple quick things here. So this is an example of south 35 degrees east, which means I went down south first, and then I went east 35 degrees, okay, which gives you this kind of a thing, where you start at the origin, and it's south and then east, just like it says there. If I gave you this one, and I asked you what's north 80 degrees west, you went up north first, and then you went over 80 degrees west, okay? So why don't you try this one? See if you can just get where this one is. North 45 degrees east. If you went, how would that land? So why don't you hit pause and then come back. Okay, if you did this correctly, it should have been like this. North first, then east, gets you up to there. All right, so those are basic things with bearings. So this one up here, the problem goes like this. You have a bearing. This is on page 360. And the question says this, you fly an airplane at 600 miles per hour and has a bearing of 52 degrees. After flying an hour and a half, how far north and how far east will the plane have traveled from its point of departure? So it's north 52 degrees east, 600 miles per hour for 1.5 hours. So the first problem is how far did you actually go if you went 600 miles an hour for 1.5 hours? Distance equals rate times time. So if I took 600 is the rate, time is 1.5. This will tell me how far I went, and if you multiply those together, you get 900 miles, okay? Which means that's how far I went over here. So that's 900. And then I got to figure out what x and y is, because they asked how far north, how far east. So if I take 52 and I can go sine of 52 equals opposite over hypotenuse, and I solve that. Okay, go sine of 52 is 0.788 equals x over 900, and solve that. Put it over 1 and multiply. You get x equals 709.2. And if I solve for y, I'm going to do the cosine. Cosine of 52 will be y over 900. And if I solve that out correctly, I should get that y will be 554.1. So there's x, there's y. Notice how I had the x going. If I made this on a graph, actually it doesn't really matter. The x is the distance east and the y is the distance north. Anyway, another one similar out of the book. If I take number 14 here, and this is a lot like number 31A on page 360, which goes like this. A ship leaves port at noon and has a bearing of south 29 degrees west. And the ship sails at 20 knots. A, how many nautical miles south and how many nautical miles west will the ship have traveled at 6 p.m.? So south would be, the y, and west would have been the x. And if it's at 6 p.m., we'll know that it'll have gone 120 miles. Okay, so anyway, one of the things that they expected you to know is that if you travel 20 knots at 6 hours, that'd be 120 nautical miles. Nautical miles is knots. Apparently, you need to know that stuff for pre-calculus too. But anyway, I'm going to use the trigonometry to solve this for x and y. Okay, so if I went sine of 29 degrees equals opposite over the hypotenuse, and if I want to know what y is after that, I can do Pythagorean theorem. So if I solve this, I will get that x will equal 58.2 miles, and that would be west. And then if I did Pythagorean theorem, if I went 58.2 plus y squared equals 120 squared, I will find out that y will be 104.9, okay? And that would be my distance. What's that? That's west, they said. Oops, y is north, sorry. Or south, north or south. In this case, it's south. Okay, so there's my two answers. And last one here. What are the bearings? So the bearings means I'm looking for the angle. Okay, so the question is the ship is 45 miles east and 30 miles south of port. What are the bearings directly back to port? So they started, went 45 miles east, 30 miles south, as you can see in my diagram. I drew the diagram. And then theta will be your bearings, okay? So I need to find out what that angle is. So I have opposite and adjacent, which means I'm looking at tangent of theta will be the opposite over the adjacent. And if I solve that out, I get the inverse tangent of 0.5, and therefore theta was going to be 56.3 degrees. So if I'm going back, I'm going to go north 56.3, and then I'll go back west. So that would be north, and then west will get me back home. This is the opposite direction of what I started. So this is my answer. All right, that's all I got for today. You guys have a great evening, and see you all soon.